Now, at the beginning of this course, we need to talk about what real numbers are. Real numbers are made up of what are called rational numbers and irrational numbers. Let's first talk about this family of rational numbers. If you look at the smallest unit in here, it's called whole numbers. Whole numbers are the numbers you learned back in first and second grade. They're whole numbers, they're positive, and they include the number 0. So we can define it down here. They're positive numbers including 0. Now, the next level in the family is called integers. Integers include those whole numbers, but also tack on a few other types of numbers, the negative whole numbers. So by definition, integers are positive and negative whole numbers, including 0. Then the next level after the integers are the rational numbers. Rational numbers include those whole numbers, they include the integers, but they go one step further and they also include fraction numbers. So anything that can be written as a fraction. Now, -1/3 can also be written as a decimal. Notice the pattern of this decimal. It does have a repeating pattern, but it also can imply that it's this fraction. Now, in higher level math, there's a family called irrational numbers. Now, the definition is right here. They cannot be written as a ratio of integers. It means any number that you cannot write as a fraction, thereby is going to be called a rational number. So if you take all the whole numbers, all the integers, all the rational numbers that can be written as fractions, and all the other numbers that can't be written as fractions, and you roll them up into one big group, that group is called the real numbers. So we typically say real numbers are numbers that can be plotted on a number line. They're all numbers except square roots of negatives. So an example of a number that might be a square root of a negative would be the square root of -2. This here is called an imaginary number, and we'll touch on that later in the year. Let's look at a quick example that asks us which numbers are considered irrational. Remember, irrational means you cannot be written as a fraction. Therefore, we can go ahead and cross off choice B and choice D. Now, on letter A and letter C, can they be written as a fraction? If you just say this number right here, you would say it's -1 2/10. Think about it this way. -1 2/10 can actually be written as a fraction. So if you look at it that way, this decimal can also be a fraction. Another way to look at it is if you don't try to make it a fraction, if you look at the decimal, if it terminates or ends, or if it has a repeating pattern, it's considered a rational number, which means it can be a fraction. So then choice C is going to be our ultimate answer. This number here cannot be written as a fraction made up of 2 integers. If we tried to make it a fraction, we could do the square root of 2/1, but the problem is the square root of 2 is not an integer. So therefore, this cannot be written as a fraction of 2 integers, and thus it's called irrational. Now that we know a little bit more about number theory, let's go to the first learning objective, is graphing numbers on a number line. Now, what I would do is, because these are of different formats, we have a decimal here, we have 2 fractions, we have a square root, is get them all in the same format. So I'm going to use my calculator, and on the calculator I'll show you how to type these in. So here's the graphing calculators we have in class, and what we're going to do to type in -2/3 of the fraction, you type the negative symbol, the 2, the division sign, and then the 3. So let me point that out to you. Here's the negative button here, so do negative, then type 2, divided by is the same as that division symbol, 3. Then you would hit enter. When you do that, you're going to get approximately 0.667. So for the square root of 2 here, we're going to type in on the calculator the square root of 2. The square root button is right there, it's a little blue guy. Notice on the calculator the second button is blue, so to get to the second level you hit second, and then this button here, and it will pop up on the screen. You'll see a square root, and you're going to type in just the number 2. So go back here and hit 2, and it'll put a 2 in there. And then to wrap it up, hit enter. Once you hit enter, it'll kick back. You're going to get approximately 1.414. Now 5/2 on the calculator, to type that in, I'm just going to do 5 divided by 2 and hit enter. And when you do that, you're going to get exactly 2.5. Now to put them on the number line, let's do this first one here, -1.2. So here's -1, here's -2. -1.2 is going to be closer to the -1, and I'm going to label it as such. Now, I don't have it written on the screen, but negative 2.3, again, was approximately negative 0.67. So I'm going to find that on our number line here. It's going to be between 0 and negative 1. It's going to be closer to negative 1, so I'm going to put it here. And I'm going to put the original format in which it was stated. It was stated as a fraction, so I'm going to actually do that. So I'm going to do negative 2/3. Now to type the square root of 2, that's about 1.4. It's going to be in between 0 or 1 and 2. It's about right here. And I'm going to label it as the square root of 2. The last is 5/2, which is the number 2.5. 2.5 is right here. And again, I'm going to put 5/2 on the actual number line. Now, if you're asked to put these in increasing order or decreasing order, we're going to get to this in the next slide, but remember, increasing means go from the smallest to the largest, so I would just look at the number line, and for increasing order, I put this first, second, third, and fourth. For decreasing order, you go largest to smallest, so I'd write this one first, second, third, and fourth. So let's formally define increasing. Increasing is from smallest to largest. And decreasing is from largest to smallest. So if they wanted us to put these 6 numbers in decreasing order, I first would want to have them all in the same format. This one here is already a decimal, and that's as a decimal. So I'm going to convert these two fractions. 5 divided by 2 in the calculator is 2.5. Negative 7 divided by 16 is going to be a negative 0.4375. The negative square root of 13 is going to be a negative 3.6 approximately. Now from decreasing would be largest to smallest. So I'm going to find the largest number first. And so I have to think, is it this number or this? Now remember, for decimals, we would say it's the tenths is the first position. The second is a hundredths. So is 10.1 tenths bigger or smaller than 10.1 hundredths? A tenth is going to be a little bit bigger than a hundredth, so this is the first largest number. So we're going to put 10.1 as first. I'm going to cross it out because I used it, and then put 10.01 next. Cross that out. The next largest number looks like it's going to be 2.5, which was originally 5/2. So I'm going to write that next. Then it looks like 1 is the next one. And then the next largest, if you think of it in terms of temperature, negative 0.4 is warmer than negative 3.6, so this negative 7/16 is the next largest. And then the last one is the negative square root of 13. If it had asked for increasing order, I would have listed this first, second, third, fourth, fifth, and then sixth. Would have been increasing order. I want to do a little bit more number vocab. So let's talk about opposites. Select all the combinations that are opposites. Be careful if you hear the word opposites in class. If it was 15 degrees outside right now, what's the opposite of that? Would be colder, negative 15 degrees. So opposite just means the sign changes. So A is not true, B is. C is not true, D is. E is not true, nor is F true. So there's only 2 of here that represent opposites. Another vocabulary word you might hear is reciprocals. Now, which ones are reciprocals? Be careful, these two, 6 and negative 6, are opposites. That's not true. What reciprocals is you flip it. So if I had the number 1/5, its reciprocal would be 5/1. So if you look at this, letter B, if I have 1/7, its reciprocal would be 7/1, which is the same as 7. But they're saying negative 7, so that's not true. Letter C is a reciprocal. That works. Letter D is close to being a reciprocal, What D is a reciprocal and an opposite. Letter E, if I take 8, I can write it as a fraction, which is 8 over 1. The reciprocal of 8 over 1 is 1 over 8, so E is the correct answer. And F is not applicable.